Okay, this is going to be super awkward, guys, but I'm going to try to teach without a class here to go over some of these, what happens to the current voltage problems. So I have another kind of brief PowerPoint that I made with just a couple of examples that we're going to do here, and in the same post that this video is in, this should be the PowerPoint as well if you want to print it off. Okay, so again, it's kind of the same as before. What happens to the current and the voltage? So in this case, what happens to the total current in the circuit? What you want to think about first is what happens to the total resistance in the circuit. And in this case, it increases because we're going from 6 here, and we're adding another one in series. So we're going from the total resistance was 6, now it's 10, so we're just going to add those two together. And when the resistance increases, the current is going to decrease. So the total current in this circuit decreases. And what happens to the voltage drop across the 6 ohm resistor? In this case, since there's just one resistor, the voltage drop from here to here is 20, so the voltage in the battery is 20. In this case, the voltage drop from here to here is 20, but now the voltage drop just across the 6, so from there to there, is going to be something less than 20. So that decreases as well. And maybe I should have said this at the beginning, but if you want to pause it and try to do it yourself, and then I'll explain it, might be the best way to go about doing these. So here's the next one. What happens to the total current in the circuit? So again, what we want to think about first is what happens to the total resistance. The total resistance in this case is going to decrease because we're adding a resistor in parallel. So when we add another path, the total current in the circuit, or the total resistance, decreases, and that means the total current in the circuit is going to increase. Okay. Next, what happens to the voltage drop across the 6 ohm resistor? In this case, from here to here, it was 15 volts, because that's the voltage of the battery. And it stays 15 volts. The voltage from here to here is 15. The voltage in this branch is also 15. When you have two resistors in parallel, the voltage across each branch is the voltage of the battery. So this is going to be, stays the same. Alright, so now on to the next one. Okay, what happens to the total current in the circuit? Alright. In this case, we did not add any more paths, but we did add another resistor in series. So these two are in series now. So this was 6, now across here is 10. So that is going to increase the total resistance in the circuit. So the total resistance in the circuit has increased because we went from 6 here, now it's 10. We did not add any more paths. So it still has 2 paths, but now one path is 10 instead of 6. So the total resistance increased, so that means the current is going to decrease. And what happens to the voltage drop across the 6 ohm resistor? So across the 6 ohm resistor initially from here to here, since these two are in parallel, it's 20 across this one and 20 across this one. So the voltage drop initially for 6 was 20. Now it's going to be 20 from here to here, but the voltage drop across the 6 ohm one is going to be something less than 20. So the voltage drop across the 6 ohm one decreased as well. So hopefully that makes sense. If you have any questions over any of these at any point, you can post them on Edmodo, and I'll try my best to answer them. I may try to do a video reply or something like that. We'll see how that goes. All right, next one here. What happens to the total current in the circuit? So kind of the same as before. We had 5 ohm up here and a 6 ohm here. Now this top part has become 12 instead of 5. So we've added it in series. We have no more paths. So the total resistance of the circuit has increased. So that means the total current in the circuit is going to decrease. Now what happened to the voltage drop across the 6 ohm resistor? From here to here, it was 15. From here to here, it was 15 as well. Now, from here to here, still 15 since there's still just one resistor in that branch. These two have changed, but the 6-1, the voltage drop has stayed the same. Right, on to the next one. I think we have 2 more left. Right, this is the last one actually. Okay, what happens to the total current in the circuit? We've added another path, so we have decreased the total resistance. This one was 4. When we add another path from here to here, it's going to be less than 4. Because now it's going to be 4. We also have an 8 ohm one, so that's going to be less than 4. So the total resistance of the circuit, because we added another path, total resistance decreases. So the total current in the circuit is going to increase. And last question here, what happens to the voltage drop across the 6 ohm resistor? So before we had a voltage drop across here and a voltage drop across here, they add up to 15. Remember, the bigger the resistance, the bigger the voltage drop, but they still have to add up to 15. So when we added this, the voltage drop from here to here now is less than it was before. I'm going to make up numbers to hopefully make it make sense. Let's say it was 5 here before. So let's say it dropped 5 volts there before. Now with this other path, it may go down to 3 volts. So if it dropped 5 here before, this one had to be 10 volts to make sure it added up to 15. But now if it's only dropping 3 volts, this one now has to be 12 volts. So the voltage drop across the 6 ohm resistor has increased as well.